I'm going to work through this problem in real time, explaining my reasoning like I would in an interview, including mistakes and course corrections. If I hit a wall after a solid attempt, I might check a solution, then break it down and code it myself. So given an array of strings, group the anagrams together, you can return the answer in any order. I see. So we're given a 1D vector and we want to group the words that have the same amount of letters frequency for them. So for instance, nat and tan, since they both have one of every letter being NAT, they're grouped in one. And this is concatenated into a 2D vector in a sense. Bat is the only one that has one B in it, while everything else doesn't have a B in it with BAT as its frequency. So if there was a tab, this would be in this part of 1D vector. So that's the my understanding of the problem. Given these constraints, we have to find a pretty fast solution for this. So, what I'm thinking of doing right now, and it's not the cleanest solution in my head, but we gotta do it in every interview. Let's use a hash map. Let's use a hash map, guys. And what I mean by that is the hash map would be going from string to as the key, and then the value would be a vector of strings. And what the key will be would be an ordered string, basically, or ordered word of the string. For instance, for example, eat would turn into AET, right? And then 8 will turn into AET. And this is how we're gonna group common words together because they have the same key. So the general gist is we're gonna iterate through strings via for loop. Then obtain the sorted word string and insert into the vector of strings given the key, the ordered key, the key ordered string, whatever. Then after all that, we're going to iterate through the hash map and populate the 2D vector answer. And I think that should be good. The It's a weird time complexity. So for TC, because it matters by the length of words. So given m is this like the actual vector length, and then n is equal to maybe max length of the like the word strings, length of words. The time complexity would be all of m log n. Yeah, because we're given this many words, and then n log n, excuse me. And then we have to sort each time for the each word. We're sorting each word to get this key value to start basically profiling each word into their corrective bins, into their bins of words or their anagrams. For the space complexity, I would assume it's the same, because we no, it's just mn. It's just mn. Because that's the amount of letters and words, basically. Yeah. So whatever the combination of letters is the space complexity. I can't think of a better solution currently. It's really hard to figure out the anagrams of each in a fast way. But in terms of like code, this would probably be the simplest. So I like this solution because it's the simplest. So I'm gonna go write that out now. Okay. I already messed up my, let's see, string. And oh, thanks for the compliment, Numkey. Really appreciate it. I try my best to explain the best I can. And this would be the, oh, actually it's not that at all. Vector of string. Yeah. And I need to, this is bothering me. This is bothering me already. And then the name of this would be anagram bins or something like that. Yeah, this makes sense for a medium problem to have this like complex data structure. Unfortunately, there might be a simpler solution, but I can't think of it right now. When I say simpler, I mean a faster solution, but I think that would entail a more complex or more data structures to use. So let's continue. Const word in strings. Oops. Oh yeah, what do you code in, Numkey? I forget what you code in. What's your programming language? Okay, so we have word. And then what we want to have is string word key. ordered word. Oh man, I already messed up. Was it B? What's next? Is it W? Yeah. And then I think, yeah. Is equal to word dot. I think it's actually just. I forget the function, so let's look up this function real quick. I think I have to do 2 iterators. Yeah. It's 2 iterators, so we're gonna do that. Yeah. Word dot begin. Oop. And then word dot end. Oh wait, hold up. I think it's in place. Okay. Yeah. Which I'm not liking this copy right now in my head. Because I feel like that would add to the space part, but it's going to be temporary. So that's the cool part about it. It's temporary. Once it gets out of the brackets, it goes off into space. Oh, right. So you do Python and Golang. I remember you're a beast in that. Yes. Ugh. Okay, so we have the ordered word now. So now we can do anagram bins dot. Nope, not dot, but it should be ordered word dot push back, since it's a vector. Push back word. So first I copied it and then I sorted it because the sort is in place, and then any liked words would be in this keys vector, or I guess key value vector. And then after that, we're going to go through this step right here, which is iterate through the hash map. Okay. If I can do that. Const auto word. I'll just call it vec words, or I guess anagrams, really. And then I should also have a vector of string. I think that's the number of bracket. Yeah. Answer. And then all we have to do is answer dot push back anagrams. The 1D vector. And it's this very simple solution right here. Okay, so let's go through a dry run. So let's do a simple. Yeah, I guess let's go through this one. Why not, guys? It might actually take too long. I don't want that in an interview. Okay. So let's see. Bins. So we get to this word, we sort it, and then we find that the ordered should be AET. And then we will have a vector that says eat. We add eat to it because it's in that, it pairs with that that ordered word, right? So we order the word, we get AET after we sort it, and then we push back the word into the vector, right? Similarly with T, we get AET. We get through this part of the line 9, and then we push back that word, right? Which is T. Then we get to tan, and this one should be ANT, ant. Hilarious. And then we push back the word, which should be tan. Then we get to 8, which would get the order of AET, getting into this for loop, which then we add in the word right there, 8, because we push back right here. Then we get to nat, which we'll get into the ANT once we order the word or sort the word, and push back there. Then we get to bat, which would be ABT, which would push back to bat. Then we start pushing back everything and get a vector similar to this, but I don't think it matters the order. It'd be very complex to like put an order in there. So that should be the overall solution. Let's test out if I have all my syntax correct. Hopefully I do. I do not, actually. I see an error already. When I was iterating through the hash map, I never actually mentioned the hash map to iterate through. So there's that. I think this should be fine. Okay, never mind. It said return anagrams. Oh, no. What am I doing? Return answer. Excuse me. Messed up there. Nice. We're able to get a solution. So I would like to do this and then this. Nice. Pretty fast solution apparently. If I submit it a couple times, maybe we get faster. But let's see if there's like better data structures at all. But I do think what we have here is probably pretty simple in terms of like line complexity. Because it took like 15 lines to write all that, which is pretty simple. And then I have like a lot of spaces, right? It's not like I try to optimize for line complexity. So let's look at like possible ways to improve like big order scale in terms of like space and time complexity, not just like minute things. Yeah, let's see this one. All right. Okay, so this person did the same thing as me with this unordered map. The thing that he did a lot better than me, right? So for this time complexity, he did what we did in the first anagram question. I forgot what question it is, but the valid anagram. So this is the way to really make it go faster, where you don't have to sort it. But basically, this would optimize for the n log n time, right? I don't know which ones is m and n, but whatever the letters is, let's say it's n, he made it into a constant time. So that is one bigger scale to utilize, but it's pretty simple. Just make sure you have the correct number of counts, and then I don't know why it's this. That's weird. He converts it back to a string of the ordered value because he's going through order from 0 to 26. And then it's the same type of what's it called? Second part solution of getting the answer into those bins. So that's one way to actually do it. I was thinking of something like this, but this felt too complex in my head. So that would drastically change the speed in terms of time complexity, but space complexity should be the same. Yeah. So I'm gonna leave it like that. I know I can implement it faster, but I like this solution. It's so simple. So simple.